Bonjour et bienvenue à la semaine française. That probably wasn't great. I did my best, Dr. St. Julian. Hopefully, you'll grade my French on a curve. Anyway, my good friend and colleague, Dr. St. Julian, has asked me to put together a French presentation here having to do with astronomy. So let's get right to it. Here's a name that I've been talking about for a long time in my astronomy class, Giovanni Cassini. And I actually didn't realize his connection to France because he was born actually in Italy. Let's take a look here at Cassini. There he is. And he was born in 1625, which was only 16 years after Galileo first pointed a telescope to the heavens. So in my class, I teach that 1609 is really the beginning of modern astronomy. So Cassini is around right at the very beginning of astronomy, and he is trained in Italy as an astronomer. Now, Galileo, one of the things that he had studied, or one of the things he discovered, were the four large moons of Jupiter, which are called still the Galilean moons. So one of the things that Cassini did early on was actually improve on Galileo's findings when it came to those moons. He calculated their orbital period around Jupiter and so forth. Anyway, he had become established as an excellent astronomer. And when King Louis XIV in France was building the Paris Observatory. And so he asked Cassini to come over to France and begin helping with the design and so forth. One thing led to another, and pretty soon three important things happened. One, Cassini becomes the first director of the Paris Observatory. Kind of cool. Two, he becomes a French citizen. And three, he actually changes his name from Giovanni to Jean-Dominique. So he is all in on France. So we're going to include him today in the French week. And there is the Paris Observatory at the time. And they were using, obviously at that time, still some pretty primitive tools and so forth for astronomy purposes. But you did have a telescope. The telescopes at the time were called refractors. And at that point, they were getting these really super long refractors for use in telescopes. Okay, as I mentioned, here are the four Galilean moons, which Cassini was able to, again, this is just a collage here, but this is the four moons, amazing moons, by the way. And so he was able to calculate things like their period around Jupiter, which was rather important at the time for various reasons I won't get into, but that was very, even for timekeeping, believe it or not, they thought that was a solution to certain problems of timekeeping at the time. Now, let's get to the planet that he is most associated with by far, and that is the planet Saturn. And Cassini discovers a few of the most important moons of Saturn. You're looking at some of them there. Hyperion, the one on the left, I always think looks like a piece of coral. That's an interesting one. And I'm going to show you a closer look at Iapetus, the one at the bottom right. Let's take a closer look at that one. That's a fascinating moon with a really cool nickname. That's called the yin-yang moon. You see it has a dark side there on the right where apparently it has, well, essentially gotten dirty as it orbited the solar system. There's some kind of soot out there and got it dirty. So that is the yin-yang moon discovered by our guy Cassini. But he did more than that at Saturn. Probably the thing that he's named after that's the most famous in astronomy, he discovered the largest gap in the rings of Saturn. And so today we call that the Cassini division, and it's the kind of thing you can see with a backyard telescope. If you have a pretty decent telescope, it's pretty easy to see. It's definitely something we look for in our own telescope in Marjorie's garden here at Stoneman Douglas High School. So that's the Cassini division. And he started speculating that the rings were not solid objects, which they aren't. They're actually just countless numbers of pieces of ice and snowballs essentially orbiting Saturn. So he began to actually piece that together based on this division that he found. Okay, so one more thing here to mention that he did that I thought was pretty impressive. One of the most important units that we use in astronomy, you know, it becomes ridiculous to use things like miles and kilometers. We should use kilometers because it's metric. When you talk about distances, really anything beyond the moon, you start using things like AUs and light years and parsecs. So he actually helped define or calculate what an AU is. He gave the most accurate measurement of the distance from the Earth to the sun. And he did this with a technique called parallax that we learn about in my class. They had instruments on basically on one side of Earth, on the other side of Earth, and they were measuring the sun. And just like if you hold up a thumb with one eye shut and you switch your eyeballs, you'll notice your thumb shifts. And so using that, the instrument on one side of the Earth and the other side, it's like switching from one eye to another, slight shift, and they were actually of the sun in this case, and they're able to measure the distance with something like 90% accuracy, I want to say, which was much better than previously. So we'll give Cassini some credit for that. Now he's doing this work, finding the moons and calculating the AU and also making maps of France and things like that. He was doing this while being the director of the Paris Observatory. And his legacy lives on in a couple ways. Most directly, the second director of the Paris Observatory, his son, Cassini II. The third director of the Paris Observatory, his grandson. And the fourth director, his great-grandson. Seriously, the Cassini family runs the Paris Observatory for well over 100 years, which I'd say is probably unprecedented anywhere in the world. I thought that was actually pretty darn cool. But in terms of his legacy in the long term, let's move ahead in time here to modern times. Here you're looking, CNES is the French space agency. Now they're going to work closely with the European Space Agency, but I wanted to mention them because they had a key role in the mission I wanted to talk to you about today. I told you we talk about a man and a mission, right? So the mission was called the Cassini mission. It's actually near and dear to me because it was sort of the first current event I ever had in my astronomy class. I started my own class of astronomy in the fall of 1997 at Stoneman Douglas High School. Before that, I was teaching physics, and this was the first current event, and I was standing in front of the class, with a cutout from the Sun Sentinel, just old school, cut out of the newspaper, and talking about this mission, and there were lots of cool things about it. But it ended up being one of my favorite missions of all time, because when it finally got to Saturn, many years later, it took about 8 years, as I remember, to get to Saturn. It was incredible. I'm going to show you one of the most incredible pictures I've ever seen in my life in astronomy, maybe my all-time favorite. But one of the things that was super exciting about the mission was being able to take a closer look at this moon right here. That is Saturn's largest moon, Titan. Second largest moon, by the way, in the entire solar system, but a fascinating world. And what had always fascinated astronomers was that it has this fuzzy peach look, and they knew it had an atmosphere. So we were going to finally be able to take a closer look. When I say take a closer look, not only were we going to get up close to it with the Cassini spacecraft, but then, this is just an artist or computer-generated model here, of course, but on board was what's called the Huygens probe. Now, Christian Huygens was another great astronomer at the time. He was from the Netherlands, and he, by the way, actually worked briefly at the Paris Observatory. But so this mission is called the Cassini Huygens mission, and the Huygens probe was going to parachute down onto Titan. And I don't know if I've ever been so excited in my career as to when that was parachuting down. We were following that in class back in 2005 and waiting for that to land. Here's the picture. This is the first time we'd ever landed on an outer solar system moon. And the picture wasn't incredibly exciting. You just have some frozen rocks or frozen chunks of methane or something there. But the pictures on the way down were fascinating, and they saw lakes and rivers of liquid, what you call like natural gas, like liquid methane. So it's a fascinating world. It's totally unique in our solar system, and that was all from the Cassini mission. But my all-time favorite thing was when the Cassini spacecraft went behind Saturn and took, again, one of the most amazing pictures, I think, in the history of astronomy. And there it is. I have to catch my breath every time I say it. That's a real picture. This is not Photoshop. This is nothing like that. And it's just stunning. And what's happening is that the spacecraft, the sun is lighting up those icy rings. And there's ring shine then that's backlighting the back of Saturn. Normally, the back of a planet would just be pitch dark. Right? It's nighttime. We're looking at the night side of Saturn, think of it that way. And instead, the ring shine is so bright from those chunks of ice that it's lighting up the back of it, and just absolutely gorgeous and incredible. And so it's been one of my all-time favorite missions. And one of the tiny dots you can see, actually, I'm trying to have trouble seeing it in this particular picture. I think that might be it right there, is actually planet Earth. It was lined up so that planet Earth was actually in the picture and photobombing the picture of Saturn. So Cassini, and it discovered so many things about Saturn and Titan and the rings, and just delivered all these magnificent pictures. And it all goes back, again, it was a tribute to the man born Giovanni Cassini. So thank you so much for listening. Thank you, Dr. St. Julian, for the invitation. And au revoir.